For over 100 years, the United States has depended on the federal and state maritime academies to produce well-trained merchant marine officers. The merchant mariners serve on a wide range of vessels that move along the U.S. coasts and inland rivers and around the globe. Their service supports the U.S. economic and security interests. Key to training these future deck and engineering officers at the state maritime academies is the annual sea cruise on dedicated training vessels. Extensive hands-on training is required by national and international standards to augment simulation and other onshore training. Seamanship and ship handling skills are honed at sea aboard these ships. Today, each of the maritime academies in the United States has a training ship owned by the U.S. Maritime Administration and operated in partnership with the academies to train future mariners. The aging training ships, the oldest of which is from the 1960s, use outdated technology which limits their training value and do not meet modern safety and environmental standards. To replace the aging ships, MARAD has embarked on a program to design modern, state-of-the-art training ships for construction in U.S. shipyards. The training ships are an available U.S. government resource found useful for humanitarian assistance and disaster response missions, as demonstrated during Hurricanes Katrina, Rita, Sandy, and Harvey. This modern, special-purpose ship is designed to provide flexible, scalable, and adaptable capabilities and is aptly named the National Security Multi-Mission Vessel, or NSMV. The new ship is optimally designed to maximize support of both missions, training, and emergency response. Key design goals for NSMV were to achieve high levels of safety and efficiency, while also being environmentally friendly in compliance with current and expected future regulations and requirements. In support of this goal, NSMV will fully meet U.S. and international safety regulations for ships carrying 700+ persons, operate full-time on clean burning, low sulfur fuel, use engine waste heat for accommodation heating, be fitted with efficient LED lighting, and have hull lines optimized for low propulsion power. Model Basin SSPA in Sweden carried out hull lines optimization using computerized fluid dynamics with results confirmed by model testing. This process resulted in a 10% reduction in propulsion power between the initial concept design and the optimized hull design, allowing one diesel generator to be eliminated. Through use of thrusters and flap-type rudder, NSMV is able to moor without tugs, very useful for undeveloped ports. NSMV can support humanitarian response missions by transporting general cargo, containers on the open deck aft, and vehicles and trailers in the enclosed roll-on, roll-off, or RO-RO for short, space below. A cargo crane, also used for training, and a side ramp allow the vessel to be self-unloading. The most important mission for NSMV is training our nation's future merchant mariners. Fully integrated and wired training spaces include 8 classrooms, a large navigation lab near the bridge, several cadet workshops, simulator spaces, and laboratory spaces. A fully equipped training bridge is located below the main bridge, where cadets can experience navigation of the vessel without interfering with actual safe navigation. A large auditorium is useful for lectures, guest speakers, and large meetings. NSMV has berthing for 600 cadets and 160 non-cadets. For increased functionality and in line with federal and industry standards, the ship has a variety of berthing spaces, including private cabins, 2-person and 4-person cabins, and other denser berthing spaces in the hull that are limited to no more than 30 in a space. The integrated accommodation spaces enable convenient access to berthing, classrooms, training, and mess areas. For humanitarian missions, the ship systems are designed to accommodate up to 1,000 people a day for 2 weeks. During humanitarian missions, when the ship can be a host to many transient workers, it is necessary to control access to command and control areas of the ship. Through the use of existing design boundaries and efficient layout, sensitive areas of the ship can be cordoned off to non-essential personnel. The habitability and engineering spaces were designed for functionality and with the operational mariner in mind. For convenience, the food storage, preparation, service, and mess areas are on the same deck, arranged for catering and service efficiency. Medical facilities on the NSMV are larger than required for a training ship and can easily be expanded to adjacent spaces by landing medical modules on deck and in the ro-ro space. Key system redundancy is necessary to ensure continuation of essential services in the event of a fire or flooding casualty in any one area. 2 separate engine rooms and 2 4,500 kilowatt main propulsion motors located in separate watertight compartments provide the needed redundancy. It also allows training to take place in one engine room while the second is used for propulsion. A diesel-electric propulsion plant was chosen because of the significant electric loads resulting from the large number of persons on board and because it allows efficient operation of the plant. Only the number of engines needed to suit the operating speed are placed online. Safe return to port in case of loss of the main propulsion system is possible through installation of a drop-down azimuthing thruster that can propel the vessel at up to 6 knots. Designing and building the ships in the U.S. using U.S. technology, materials, and labor will help ensure continued development of the country's shipbuilding base for the construction of modern, advanced ships incorporating the latest technology. By replacing the aging fleet of training ships with the NSMV, America's future merchant mariners will continue to be well-trained and well-equipped to handle all that the sea throws at them. And the U.S. will have available for quick activation multiple humanitarian assistance and disaster response ships ready to lead recovery efforts in case of a major hurricane or natural disaster strikes our coastal regions.